Okay. So let me talk a little bit about safety standards for the management of radioactive waste. The IAEA is the International Atomic Energy Agency, is a UN organization which was formed in 1957. And one of their tasks is to establish or to ensure safety of nuclear applications. And this is already said in the statute. It says to establish standards of safety for protection of health and for the application of these standards. And so the IAEA, we have developed a number of safety standards which have a hierarchical structures. On top of this hierarchy, there are the so-called fundamentals. These are only 10 main objectives to ensure safety and protection of people from nuclear applications. Of course, we have a wide range of nuclear applications, and so for any specific application, or for a group of application at least, there are so-called safety requirements. This means what to do in general to ensure safety, for example, in the field of pre-disposal management of waste. This is still a high-level document which covers more the general issues and topics to be addressed to ensure a safe management of waste. And to give more guidance, there are the so-called safety guides, and which give more detailed guidance what to do in a specific, for the application of a specific activity. And it is related to on best practice, on experience made in member states, and to meet the requirements, how to do what the requirements request. So there's, for example, one standard is the disposal of radioactive waste. And there are more. This one is about general safety of facilities and activities. And then they address the different aspects of management of waste. Pre-disposal management, this means this is any activity which occurs before the waste is disposed, and then the disposal, then during the disposal. Also decommissioning of facilities, because over there a lot of waste will be generated. Waste disposal covers a wide spectrum of activities. Waste management covers a wide spectrum of activities. And these are all administrative and operational activities which are involved in handling, pre-treatment, treatment, conditioning of waste, its transport, the storage, and finally also the disposal of radioactive waste. So this disposal is the last and very important activity of a long list of activities in between. So why do we need disposal? Of course, it's quite simple. The alternative would be storage, and storage can always be only a temporary solution. Radioactive waste contains partly very long-lived radionuclides, which live much longer than our which have of 100 or 1,000 years, and this means storage is not sustainable on the long term because it requires active control for safety and security, and there are ongoing responsibilities and costs. And this would mean that also future generation would have to be responsible and would have to spend resources on the waste that is produced and generated in presence. And as you see, there are events and developments which could have an impact on safety and storage. First of all, wars and terrorism, where everything gets out of control, but also urban growth, natural events like storms, floods, earthquake, or volcanic eruptions. So disposal is really a need. So, therefore, disposal facilities is also a key topic of the IAEA, within the IAEA safety standards. And this specific safety guide gives an overview of the geological disposal and its implementation, about legal and organizational infrastructure, about the safety case and safety assessment, and also it illustrates a stepwise approach to the development of a geological disposal facility. This stepwise approach is needed because usually the setup of a disposal facility takes very long time, and so different steps are defined to go forward. Another point I would like to explain is the safety case. Maybe you have not heard it so far. And the safety case, this is a comprehensive evaluation of the safety assessment. And in particular, evaluates the findings of the safety assessment and provides a statement of the confidence of these findings. It will also address weak points of the safety assessment and how to overcome those weak points. So this is the safety case and safety assessment go hand in hand, and the safety case is, so to say, a comprehensive, holistic view on the safety of a disposal facility. Coming back to this stepwise approach, here you have a timeline. We have several periods. This is the pre-operational period, the operational period, and the post-closure period. And this shows the different activities, for example, pre-construction activities, construction activities, the operation, closing, and then the post-closing activities. And post-closing activities also include, at least for limited time, some institutional control. On the long term, a disposal facility has to be designed as such that no institutional control is needed. And to give you an idea about this timeline, you can imagine that before the pre-construction activities is about at least 10 years. Construction will be maybe another 10 years. Operation is usually something like 50, maybe to 100 years. This depends on the host rock and on the specific design, but at least some decades. Closure will be done probably a bit faster, and by the end of the day, post-closure is something for eternity. But here, no longer institutional interventions are needed. So, the requirements for safe disposal. First of all, there's a site characterization. And this is to support the general understanding of the characteristics of the site, and because we have to look at long time frames, also how the site will evolve over time. And there are several possibilities depending on the site. For example, the Swedish site will be constructed on an area which is undergoing an uplift since the last ice age. The whole area is lifted by 6 millimeters per year. The implications of such developments have to be addressed and have to be studied in the site characterization. And the next one is the design, and of course the facility shall be designed in such a way to provide operational and post-closure safety. This is what disposal is about. And the construction of this facility has to be as such that this objective is fulfilled at any circumstances. The operation, the disposal facility during operation is a normal nuclear facility, and so it has to be operated in accordance with the IAEA safety standards or with the relevant national regulations. And the closure, the facility shall be closed to provide the safety function shown in the safety case, which are important to be safety over a long period of time. So, to demonstrate long-term safety requires a safety assessment. And safety assessment is a key activity of the IAEA to provide guidance to ensure safety for a wide range of facilities, and disposal is one of them. And within the safety assessment, this requires the evaluation of the overall performance of a disposal system. And the disposal system comprises of the host rock, the area where the waste is stored, the overlaying rock, and then the biosphere. And the safety assessment requires a systematic assessment of all radiation hazards, and it has also to quantify the radiological impact both in operation and post-closure. So this is a scheme of such a disposal system. This is a confinement with a waste, and the waste is usually is packed and has some additional matrix overpack. Then there are seals, and the idea is to isolate the waste for a long time from the biosphere. Nevertheless, in all safety assessments, there is the idea or scenarios are considered which might cause in the far future a migration of radionuclides from the confinement area to the biosphere. And based on this data, on this prediction, what activity could appear in the biosphere, an assessment of doses to people is made who live in this area which could be affected in the far future. So it is, the safety assessment is a complex document, and this is just an idea what all is necessary, what all has to be considered and addressed in the safety assessment. This is a management system in general, whether the company who is responsible for the waste does a good job. Then we have the non-environmental impact. We have the operational safety and the site and engineering. And to estimate the post-closure radiological impact, the scenarios, models, and calculations have to be described in detail. Okay, within our problem, what we have within the ENEP program, we are not looking in detail to all these effects and phenomena which occur in the underground. We focus more on the biosphere part and on the assessment of potential doses to people who live in this area. So some guidance for this problem is also given in this safety standard. Regarding the radiation protection objective in the post-closure period is the following. And the safety objective is that to site, design, and construct, operate, and close the disposal facility, so that protection is always ensured. And it has also been demonstrated that doses and risks in the long term will not exceed the dose constraints and risk constraints which are used as a design criteria. And coming to the criteria for members of the public, for any facility which is planned, the dose limit is 1 millisievert per year. And also this criteria should not be exceeded in the future. This 1 millisievert per year is due to the exposure from all nuclear facilities in an area. It might well be that in an area there are 2 facilities or 3. But by the end of the day, each individual should not receive more than 1 millisievert per year. And therefore, a dose constraint is introduced, which is a dose limit for a specific installation rather than for all nuclear installations on a specific site. And this 0.1 millisievert per year, according to the risk factors published by the ICRP, by the International Commission of Radiation Protection, this is a risk of 10 to the minus 5 per year. Let us look for some criteria in national facility, disposal facility projects. There's, for example, Sweden, which is currently undergoing licensing. There's a risk constraint of 10 to the minus 6 per year, and this is approximately equivalent to an annual dose of 20 microsievert. For comparison, the exposure from natural background is about 2.4 millisievert per year, so this is about 1% of the natural exposure. Finland has different criteria. The doses to the most exposed people should be below 0.1 millisievert per year. And for those who are not most exposed, the dose should be very, very low, insignificantly low. And for the time frame, it is required to look for the assessment for several thousand years. And then Finland said there are no longer detailed dose assessment necessary, but they give a constraint on the radioactive release to the environment. And these releases, because these are very long-term processes, could be averaged over 1,000 years. Coming back to Sweden, with regard to the time frame considered, for the first year, a quantitative assessment is required, and for times longer than 1,000 years, a sequence of possible developments should be considered, and these assessments should be as long as barrier function of the disposal is required, but it should be at least 10,000 years. You see, all these radiological criteria remain below 1 millisievert per year, but the details differ from country to country. France says the risk constraint is equivalent to a dose of 0.25 millisievert per year, and 10,000 years should be looked at for safety demonstration. In Germany, those criteria are still under discussion. So far, the criteria for high-level waste disposal facility is 10 microsievert per year, which is even lower than in Sweden. And the time frame of this closure is also still under discussion. That for 10,000 years, detailed assessment should be made, and then for 1 million years, a more stylized, a more simplified assessment can be done to demonstrate this long-term safety. So, when the safety guide SHG 14 regarding the post-closure safety assessment, it is said that radiation exposure is a major safety issue, and it has to be developed. Such exposure assessment has to be developed, and also confidence in the modeling has to be provided. And confidence is often provided if all assumptions are very conservative. This means very pessimistic. However, another requirement here is that the conservatism should be reasonable. It should be not overly conservative. So it should have some degree of realism. And it's also said that any approach to make an acceptance easier, because we look at long time frames, and to look at over long periods of time to complex systems is very difficult. That's why it is suggested to try to look for simple approaches. And the ideal approach is, of course, someone which balances simplicity, conservatism, and realism. And this is considered as a best starting point. But this is also a best, kind of a best wish. And for looking for the dose assessment, for looking for compliance with safety objectives and criteria, it is assumed that in estimating doses to individuals in the future due to a disposal facility, people will be present locally, even if it's in the middle of a desert. But people have to be around, otherwise there is no dose. And it should also be assumed that people make some use of the local resources that may contain radionuclides originating from the waste of the disposal facility. So there's a requirement to look specifically to those scenarios which could cause a migration of radionuclides from the disposal area to the biosphere. However, since it is not possible to predict the behavior of people in the future with any certainty, it is suggested that assessment models need to be stylized, simplified. And there was an IAEA project which is called biomass over in the 2000 years, and the biomass project discusses in detail the rational and possible approaches to modeling the biosphere and the estimation of doses arising from waste disposal facilities. And this biomass methodology, they have different flowchart with different steps. First of all, it deals with the assessment context. Where is the disposal site and what kind of waste will be disposed of there? Provide a detailed description of the disposal system. Develop scenarios, in just the scenarios for the assessment of exposures to people. Develop appropriate assessment models. Do calculations and analysis of the doses. And then the question is this model, does it address appropriately the site? If yes, then comparison with the criteria. And if no, do it again. Details about this methodology will be given in one of the next presentations. And the report has been prepared of the biomass project on the development of reference biosphere for solid radioactive waste disposal. So, finally, I have some conclusions. We have seen that the IAEA has developed safety standards on the disposal of radioactive waste. The safety assessment for a waste disposal facility has to cover all components and aspects of a facility, including the host rock, the waste packages in the confinement, geology and hydrology, and exposures to people in the biosphere. The radiological criteria in the post-closure period are well below 1 millisievert, and the time frames to be considered are up to 1 million years, and this depends on the country. And the IAEA has developed a methodology to set up assessment models for its exposures in the far future. Thank you very much.